Good afternoon.
Good afternoon, sir.
Good afternoon, sir. Good
Thank you.
afternoon.
Good afternoon to everyone.
Good afternoon, sir.
Good afternoon. So today the first problem is find sine series for the function. Please write f of x is equal to 1 by 4 minus x in the interval 0 comma half x minus 3 by 4 in the interval 1 by 2 comma 1. Okay. Uh, so So here the function is actually find the sine series means we need to find half range sine series. So the interval is 0 to half and half to 1. Okay, so sine series means you should give an odd extension. Okay, I should give an odd extension for this function. So I will roughly I will do it, but it is not necessary. It is necessary, but for exam point of view, it is not necessary. Okay. Uh, so in the interval minus half to 0, the interval minus half to 0, we should define how you will extend odd extension of this function. 1 by 4, that is f of x is equal to what? Minus of
1 by 4 plus x.
Phi of minus x are there.
Yes,
Is it
sir.
correct? Okay, this is equal to minus of phi of minus x is what? 1 by 4 minus of minus x is what? Plus x. Is it correct?
Yes, sir.
Okay. So in this interval, minus half comma 0. So similarly, you should define f of x is in the interval minus of minus phi of x in the interval minus 1 comma minus half. So that is equal to what? Minus of minus x minus 3 by 4. So that is equal to x plus 3 by 4. X plus 3 by 4 in the interval minus 1 comma minus half. In the interval minus 1 comma minus half. So your function f of x is defined from where to where now? From minus 1 to plus 1. So 2L equal to 2. So L equal to, okay, here 2L equal to 2. This implies L equal to 1. Okay. So just I'll keep as it is. Maybe if you want to refer later, you can refer it. So just I'll keep. Okay. So now I need half range sine series, that is f of x is equal to summation n equal to 1 to infinity bn into sine n pi x by L. L is 1. So now I need to find what? Bn. So Bn equal to 2 by L. So 2 by 1 integration 0 to L. L is 1 into f of x into sine n pi x by L. L is 1 into dx. So now the remaining part is you need to substitute, you should split it to 0 to half and then half to 1. So which is equal to twice 0 to half. So in this interval the function is what? 1 by 4 minus x. 1 by 4 minus x into sine n pi x into dx plus half to 1. In this interval f of x is x minus 3 by 4 into sine n pi x by 1 into dx. Plus bracket. So now integrate. So we'll get a 2 into 1 by 4 minus x. So minus, if you integrate this, you get minus cos n pi x by n pi. Minus, if you differentiate this, you'll get minus 1. If you integrate this, you'll get minus sine n pi x by n square pi square. So limit is from 0 to half. Okay, plus 2 into if you integrate this function, you'll get what? X minus 3 by 4. Okay, into if you integrate sine n pi x, you'll get minus cos n pi x by n pi. Minus, if you differentiate this function, x minus 3 by 4 will get 1. If you integrate this function, you'll get minus sine n pi x by n square pi square. So the limit is from half to 1. Okay. So now you should apply the upper limit. So if you substitute n equal x is equal to half, 1 by 4 minus half is minus 1 by 4. So okay, plus sorry, equal to 2 into 1 by 4 minus 1 by 2 is minus 1 by 4. Minus 1 by n pi. That's 1 by n pi. And then cos n pi x is equal to pi by 2. So cos n pi by 2. And then 3 minus, so minus 1 by n square pi square. Minus 1 by n square pi square into sine n pi x is 1 by 2. So sine n pi by 2. Sine n pi by 2. So this is actually upper limit. This is upper limit. Minus lower limit is when x is equal to 0, you have minus, okay, keep minus here. When x is equal to 0, this is 1 by 4. 1 by 4 into when x is equal to 0 minus 1 by n pi. Minus 1 by n pi. Okay, and then when x is equal to 0, sine 0, 0. Minus 0, close the bracket. So this is for, the bracket is for lower limits, and then close it. Okay, and then plus 2 into, again, when x is equal to 1, 1 minus 3 by 4 is 1 by 4. Here minus 1 by n pi, minus 1 by n pi, and then when x is equal to 1, cos n pi is minus 1 whole power n. Okay, and then when x is equal to 1, cos n pi is 0. Okay, so plus 0. So upper limit is over minus lower limit. Lower limit is 1 by 2. So 1 by 2 minus 3 by 4 is minus 1 by 4. Minus 1 by 4 into minus 1 by n pi into cos n pi by 2 into cos n pi by 2, and then minus into minus plus plus 1 by n square pi square into sine n pi by 2. Lower limit close bracket and close this bracket for square bracket. Okay. Now you can see here this term. Okay, here minus into minus plus 1 by 4, 1 by n pi cos n pi by 2. But here have minus 1 by 4 1 by n pi cos n pi by 2. So these two terms are gets cancelled. So here this is actually minus 1 by n square pi square sine n pi by 2. Here also you have minus 1 by n square sine n pi by 2. You can add. So these two terms, so which is equal to, I took 2 is common. So first I will write this term, minus of minus plus 1 by 4 n pi and then minus 2 times this function, 2 times n square pi square into sine n pi by 2, and finally you have one more term minus 1 by 4 n pi into minus 1 whole power n. So throughout multiply by 2, you'll get 1 by 2 n pi minus 4 by n square pi square into sine n pi by 2 minus 1 by 2 n pi into minus 1 whole power n. So this is actually Bn. So therefore f of x is equal to summation n equal to 1 to infinity Bn. So write this function 1 by 2 n pi minus 4 by n square pi square into sine n pi by 2 minus 1 by 2 n pi into minus 1 whole power n into sine n pi x by L is 1. So problem is over. So next problem is find subdivision 1, Fourier half range cosine series. Okay, and subdivision 2, Fourier half range sine series of the function
Sir.
f of, yeah, please tell.
Sir, please show previous slides.
Okay,
1 minute, sir.
okay, it's okay. No problem.
Sir, can we simplify this further? If n is even, then this
N
will
is
be
even,
zero.
this is 0.
Yes, sir.
Okay, yeah, you can simplify. When n is even.
So full term is 0. Bn is 0.
Oh, yes, here also, this is about n is even. Yes, these two gets cancelled. Yes, you are right here. When n is even, everything is 0. So only thing we take care about when n is what? odd. Okay, wow. So I should do before the this step. Okay. So otherwise, so here, okay. Can I write here summation n equal to 135? Okay, wow, up to infinity 1 by 2n pi minus 4 by n square pi square. Okay, into sine n pi by 2 minus 1 by 2n pi minus 1 whole power n into sine n pi x. So still you can okay
So that
when
minus 1 whole power n we can combine with this 1 by 2 n.
minus 1 whole power when n is odd, this is what minus 1 minus of minus 1 plus 1 so plus 1 means 2 times 2 times 2, so 1 by n pi, is it correct?
Yes, sir.
1 by n pi so into sine n pi x, but still you can simplify. That means you need to write n equal to 1 to infinity means you should write n, you should replace n by what?
2n
2,
minus 1.
yeah, 2n minus 1. You should replace n by 2n minus 1 everywhere. So I leave that part to you. So first you should write here Bn is 0 when n is even, and Bn equal to 1 by n pi minus 4 by n square pi square into sine n pi by 2 when n is odd, and then you should write this step. So if you want to write from n equal to 1 to infinity, you should replace n by 2n minus 1.
So can we
Thank you.
leave the problem in the previous step itself, like where f of x is n is equal to 1 to infinity, the bigger term that comes.
Sorry, Varsha, I'm not hearing properly. Please
So
tell again.
in the term which you had left, sir, in that
Uh,
term, sir, can we leave f of x like in the examination and all?
in the examination,
Yes, sir.
uh, yeah, I think your question is whether we can write this step or otherwise we need to write like this. Is it
Yes,
correct?
sir. Yes, yes, sir.
Yeah. Okay. So it is better to write simplify uh, uh, because initially when I am solving, I am not listening. So this term. So it is better to do most simplified form. So that is my suggestion. So sometimes the mark difference is maximum. They will reduce 1 mark. So this for I am telling for exam point of view. Okay. So suppose if you want to get full marks, so you should try in the most simplified form. So that is, but it is depending upon the examiner. So again, okay.
Yes, sir.
Okay. Now find subdivision 1, Fourier half range cosine series, and the subdivision 2, half range sine series of f of x. This is the function x. So first I will check it in the book, this problem. Okay. So whether I don't have, what is the problem? N by 4 minus 6 half range. See, so I want to check it. Quickly I'll check it. 0 to half, 1 by 2 to 1. Yes. So actually, the book they simplified, but I'm not listening properly. I'll give the final answer. The final answer is, I'll tell you the final answer. Actually, you should write here Bn equal to 0 when n is even. Okay, va? Similarly, when Bn n is odd, you know that this is actually minus 1 minus of minus plus 1 by 2 pi plus 1 by 2 n pi. You'll get 2 times 2 divided by 2 n pi, you'll get 1 by n pi. So when n is odd, you have 1 by n pi minus I have 4 sine n pi by 2 by n square pi square, but in the book they write 2. How it is 2? How it is 2? Okay, so I'll keep it. This is 4. Okay, because I have 4 only here. I have 4 only. Okay, and the final answer is you should replace n equal to 1 to infinity 1 by 2n minus 1 into pi minus 4 times sine of instead of n 2n minus 1 into pi by 2 divided by 2n minus 1 whole square into pi square into sine of 2n minus 1 into pi x. And the book answer and my answer differs only here. Here I have 4, but in the book it is 2. I don't think I done the mistake. Maybe in the book we have the typo. Maybe it's a typo. Suppose if you find a mistake, you can point out. So this is the final answer. Okay, thank you. And then I'll go to the next problem. Find subdivision 1, Fourier half-range cosine series, and subdivision 2, Fourier half-range sine series of f of x. X is in the interval 0 to 1, and 2 minus x in the interval 1 to 2. Okay. So let the half-range cosine series be f of x is equal to what? A0 by 2 plus summation n equal to 1 to infinity an into cos. What is L here?
2.
Yeah, L equal to 2. So you need to define you need to define an even extension. Okay, well, similarly, you need to define even extension. So L should be 2. So this is half range cosine series. So A0 by 2 plus summation n equal to 1 to infinity an into cos n pi x by 2. And A0 equal to what? 2 by 2. 2 by L. 2 by L. L is 2. Integration from 0 to L. L is 2 into f of x into dx. Okay. So now it should split into 2 integrals. One is from 0 to 1, another one is from 1 to 2. So 0 to 1, what is f of x? X. And then 1 to 2, what is f of x? 2 minus x. So now if you integrate x, you will get x square by 2, 0 to 1, plus if you integrate 2 minus x, you will get 2 minus x whole square by 2, and then here is come minus x, so minus 2, limit is from 1 to 2. So upper limit 1 by 2, lower limit is 0. So I took minus 1 by 2 commonly. When x is equal to 2, 2 minus 2 is 0, upper limit. When x is equal to 1, 2 minus 1 is 1 square is 1. So 1 by 2 plus 1 by 2. So a not equal to 1. So next I need to find an. An equal to again 2 by L. L is 2. L is 2. Integration from 0 to 2 f of x. F of x into cos n pi x by L. L is 2 into dx. So you need to split into two integrals. One is from 0 to 1, another one is from 1 to 2. So in this interval, f of x is what? X. In this interval, f of x is 2 minus x. So now integration by parts. So keep x. If you integrate cos n pi x by 2, you get sin n pi x by 2 divided by n pi by 2 minus minus. If you differentiate x, you get 1. If you integrate this function, minus cos of n pi x by 2 divided by n square pi square by 4, limit is from 0 to 1. So next I need to integrate this function. To keep 2 minus x, if you integrate cos n pi x by 2, you get sin n pi x by 2 divided by coefficient of x is what? N pi by 2 minus, if you differentiate 2 minus x, you'll get minus 1. If you integrate this function, you'll get minus cos of n pi x by 2 divided by n square pi square by 4. Limit is from 1 to 2. Okay. So I need to simplify further. Okay. So please tell. So if you substitute x is equal to 1, what happened? So 2 by n pi, 2 by n pi. Okay. 2, because this is 1, 2 by n pi sin, sorry, here x is equal to 1. 1 means 2 by n pi sin n pi by 2. X is equal to 1. Sin n pi by 2. Plus minus of minus plus 4 by n square pi square. By n square pi square cos n pi by 2, because x equal to 1, cos n pi by 2. So upper limit is over, minus lower limit. When x is equal to 0, 0, here lower limit is 0, plus, because minus of minus plus 4 by n square pi square, cos 0 is 1. So we have only 4 by n square pi square. Okay. So now plus upper limit. When x is equal to 2, 2 minus 2, 0. Okay. Upper limit is 0. And then here, what is the upper limit? Minus 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 4 by n square pi square. So 3 minus, so minus 4 by n square pi square. Okay. And then when x is equal to 2, 2 gets cancelled. Cos n pi means minus 1 whole power n. So upper limit is over. Minus lower limit. Lower limit when x is equal to 1, 2 minus 1 is 1. So 2 by n pi sin n pi by 2. Okay, so here it is over. Next minus minus minus. So minus 4 by n square pi square. Minus 4 by n square pi square. Okay. And when x is equal to 1, cos n pi by 2. So close the bracket. Okay. So now you can see, you can cancel these two terms. Okay. And then, yes, you can add these two. So if you add, you'll get 8 divided by n square pi square into cos n pi by 2. Okay. From these two, this is also minus sign, here also minus. So what is common? Minus 4 by n square pi square is common. Remaining you have 1. Here you have plus minus 1 whole power n. So now you can write this is equal to, when n is odd, okay, when n is odd, this is minus 1, so this is 0. When n is odd, cos n pi by t is also 0. So both of them are 0. So 0 if n is odd. Okay. Similarly, when n is even, just I will write if n is even and I took n equal to 2m. Okay, so then 8 by n equal to 2m means 4m square into pi square into cos n equal to 2m pi by 2 minus, when n is even, then this is plus 1. So 1 plus 1, 2. We have minus 8. Minus 8. N equal to 2m means 4m square. 4m square pi square. So, if you, okay, I'll rewrite the next page. Zero if n is odd. Okay. And if you simplify this, you'll get 2 m square pi square 2 divided by m square pi square into cos 2 gets cancelled, cos m pi. Cos m pi is minus 1 whole power n. Okay. And minus 2 by m square pi square. If n is even and n equal to 2m. So, okay. So this is equal to, so again I will write 0 if n is odd. So you think you can take commonly what? 2 by m square pi square. This is cos m pi is minus 1 whole power n, not n, m minus 1. So if n is even and n equal to 2m. Okay. So now we know that n is odd. We know that if n is odd, this is it is an. Yeah, an is 0 or n is odd. So now, what about when m is odd or m is even? Now, so that is my next case. Okay, so I will write here. So now m is even. M is even means m equal to, because n equal to 2m, so m equal to n by 2. N by 2 is even. So next case, m equal to n by 2 is odd. Okay. So when m is even, this is plus 1 0. Okay. Now when m is odd, what happened? This is odd means minus 1 minus 1 minus 2. So minus 4 divided by m square pi square. Okay. So now the next question, when n by 2 is even, for what values of n by 2 is even? Again, I will repeat the question. For what values of n by 2 is even?
Multiples of 4.
Yeah, n should be multiple of 4. Yes, correct, Jaya. Okay.
So can you show the previous slide, sir?
Okay.
No, 1 minute, sir. Yes, sir. Thank you.
Okay. So now this is equal to 0. Okay. If I'm writing in terms of n, so n should be multiple of 4. If multiple of 4. Okay. So now, what is the other case? What is the other case here? This is n is multiple of 4. Then it should be what?
Two, 6, 10.
Sorry, Jaya, please tell. Okay. So when n is odd, everything is 0.
So
Okay.
2, 6, 10.
Yeah. N is multiple of 4, then it is also 0. So what is the remaining possibility? Yeah, 2, 2, 3, 4, 5. Is it correct?
So 6.
6, and so on. Okay, so that's
So
why I
not
write.
5.
Sir, 5 is odd number. Only even numbers.
So n should be even. Okay, n should be even, but n is not multiple of what?
4.
4. N is not multiple of 4. Okay. Okay. That means I'm going to substitute here m equal to n by 2. M equal to n by 2 n square by 4. So 4 is going to numerator. So minus 16 by n square pi square. Minus 16 divided by n square into pi square. So here I replaced m equal to n by 2. Okay. So now I think up to this is enough. Now what is f of x? So please tell. A naught. What is a naught?
1.
1. Okay, thank you, Varsha. So 1 by 2. And then here it is what? I wrote. Okay. Okay, what is constant? Constant is minus 16 by pi square is constant. Okay. Summation. I don't want to write in the form of summation. So that's why because when n is odd, we know that 0. So okay va. So next n equal to 2 varuma. Okay, so 2 will come. So because here have n square, so 2 square into cos n is 2 pi x by L is 2. I think L is 2. Please check it. L is
Yes.
2.
Yes, sir.
Yes, correct. N equal to 1 is 0. N equal to 2 will come. N equal to 3, 0. Because odd. N equal to 4 is a multiple of 4. Again, it is 0. N equal to 5, odd. Okay, 0. N equal to 6 will come because it is even, but it is not multiple of 4. So 1 by 16 divided by pi square. Here we have 1 by n square. Okay, so 6 square into cos 6 pi x by 2. 7 will not come. 8 is multiple of 4. 9 is odd. 10. 1 by 10 square cos 10 pi x by 2 and so on. Okay. So now I think, sorry. If you want to write, you can write one more step. F of x is equal to 1 by 2 minus 16 by pi square 1 by 2 square cos pi x plus 1 by 6 square cos 3 pi x plus 1 by 10 square into cos 5 pi x plus and so on. So this is the final answer. So if you want to cross check your answer is correct or not, you can go here. So I think this is the last step. So without any simplifications. So from here onwards only you are doing odd even case. So if you want to check, you can substitute n equal to 1, n equal to 2, n equal to 3, n equal to 4. Okay, whether you are getting this term, you can check it later, not now. Okay, now
Sir,
yeah, please do.
sir, we can write this also in terms of summation sign.
Uh, this is enough. How you want to write in terms of summation means how you 2, 4, 10 you are going to extend. Okay,
Yes, sir,
what
4n minus 2.
4 and minus 2 are okay. Please, so sorry. F of x is equal to 1 by 2 minus 16 by pi square r. Okay, summation. What? 1 by 4 and minus 1.
So 2, 4n minus 2, sir.
4 and minus 2. When n equal to 1, it will get what? N equal to 1, 2. N equal to 1, 2. Okay, n equal to 2 will get 6. Yes. So you have a series. Okay, 2, 6, 10 like this. Okay, so a plus n minus 1 into d. A is 2 plus n minus 1 into d is common difference is 4. So 2 plus 4n minus 4. So 4n minus 2. Okay. So this is 4n minus 2 whole square, correct? Okay, and then what 135. Okay, so 135 is what 2n minus 1.
Yes, sir.
Okay, so cos 2n minus 1 into pi x. Yes, pi x. Yes, correct, Jaya. Thank you.
Further also 2 we can take common from
Okay.
denominator.
Here you are going to take 2 common.
Yes, sir.
Okay, so leave it. That part, I think you can do it. Uh, f of x is equal to 1 by 2. If you take 2 commonly, it means 2 square 4. 4 means here 4 by pi square, summation n equal to 1 to infinity 1 by it took 2 commonly means 2n minus 1 1 square into cos of 2n minus 1 into pi x. Okay, okay, good. Thank you, Jaya. And then there are 2 parts in the question. So the second part is half range sine series. So the half range sine series is f of x is equal to summation n equal to 1 to infinity bn into sine n pi x by L. L is 2. Bn equal to what? Bn equal to 2 by L. L is 2. Integration from 0 to L. L is 2. F of x into sine n pi x by L. L is 2 into dx. So you should split the integral into 2 parts. One is from 0 to 1. Another one is from 1 to 2. So in this interval, f of x is x. In this interval 1 to 2, f of x is what? 2 minus x. So now you need to integrate. If you integrate, you'll get what? X into, if you integrate sine n pi x by 2, you'll get minus cos n pi x by 2 divided by n pi by 2 and then minus, if you differentiate x, you'll get 1. If you integrate minus cos of this function, you'll get minus sine of n pi x by 2 divided by n square pi square divided by 4. Limit is from 0 to 1. So this is over. So next I need to integrate this function. If I integrate this function, you should keep 2 minus x. Okay, 2 minus x as it is. If you integrate the sine n pi x by 2, you'll get what? Minus cos n pi x by 2 divided by n pi by 2. And then minus, if you differentiate 2 minus x, you'll get minus 1. If you integrate this function, you'll get minus sine n pi x by 2 divided by n square pi square by 4. Limit is from 1 to 2. Okay, so now I need to substitute the limits and then I need to simplify further. Okay, if I substitute x is equal to 1, minus 2 by n pi minus 2 by n pi into cos n pi by 2. Okay, and then minus of minus plus 4 by n square pi square into sin n pi by 2. 4 by n square pi square into sin n pi by 2. So actually this is the upper limit. Okay, this is the upper limit minus the lower limit. When x is equal to 0, totally 0. When x is equal to 0, sin 0, 0. So 0 minus 0. Okay. And then second integral, when x is equal to 2, 2 minus 2, 0. And then minus, minus, minus. When x is equal to 2, 2, 2 gets cancelled, sin n pi 0. Minus lower limit. When x is equal to 1, 2 minus 1 is 1. So minus 2 divided by n pi when n is equal to 1, cos n pi by 2. Okay, so now minus 3 minus, so minus 4 by n square pi square. Okay, when x is equal to 1, you get sin n pi by 2. So I think you can see these two terms are cancelled. You have minus, minus of minus plus. So we are calculating Bn. So Bn equal to here plus, here also plus. So 8 by n square pi square. 8 by n square pi square into sin n pi by 2. So this is your function. When n is even, this is 0. Okay, n equal to 2, 4, 6, this is 0. So when n is odd, I just keep as it is. So what is the function? 8 by n square pi square to sin n pi by 2 if n is odd, and 0 if n is even. Okay, so now
So could you show the previous page, sir, once?
okay,
Yes.
so now this is equal to when n is odd. So what is f of x? F of x is equal to bn summation n equal to 1, 3, 5 up to infinity. 8 is constant. 8 by pi square is constant. 1 by n square into sin n pi by 2. Okay, so now you can write 8 by pi square. If I want to write in terms of what? 1 to infinity. So you should write n is what? 2n minus 1. 2n minus 1 means if you substitute n equal to 1, so you get 1. Sorry? Yeah, n equal to 2 means 4 minus 1, 3 square. Okay. So you'll get a sine. Instead of n, you can replace 2n minus 1 pi by 2. So I think you can stop here. So, but the book answer, they write like this. Okay, you can stop here, but if I also write the book answer, 8 by pi square into, we substitute n equal to 1, 1 by 1 square into sine pi x, I think I missed x, n pi x by 2. So pi x by 2. N equal to 2 means 1 by 3 square.
Sir,
Yeah.
so there will be sin n pi by 2 also. So
Okay.
sin n pi x
Yeah,
by
yeah,
2.
yeah. Please wait, please wait. Sorry. This is actually Bn, okay, into sine sine n pi by n pi x.
Yes, sir. X by 2.
X by 2. Is it correct? Now it is correct. I'm asking about this step.
Yes, sir.
Okay. So now I need to change. I think I need to replace n by 2n minus 1. Okay. Here into again sign r. You have two signs r. Okay. Here you have n pi by 2. Okay. Please wait. Into sine here, sorry. Again, I need to replace n by what? 2n minus 1. 2n minus 1 pi x by 2. Okay. So if I substitute n equal to 1, what happened? Please tell. If you substitute n equal to 1, 8 by pi square into 1 by 1 square. Okay, well, if n equal to 1, this is sine pi by 2. Sine pi by 2 is 1. Okay, well. So either this is because this is odd pi by 2. Either this is 1 or minus 1. Okay, well. Either 1 or minus 1. So,
Sir,
yeah,
can we write it as minus 1 power n minus 1?
yeah, this one, minus 1 power n plus 1. You can, if you want to write, you can write. Because when n equal to 1, this is plus 1. Okay, well. N equal to 2 means minus, yeah. Yes, you are right. So directly you can simplify this one. So this is equal to 8 by pi square summation n equal to 1 to infinity. Instead of sine n 2n minus 1 pi by 2, you can write minus 1 whole power n plus 1 divided by 2n minus 1 whole square into sine of 2n minus 1 into pi x by. So I will write one more step. That is the last step. Please tell. I think this is enough. This is enough. Substitute n equal to 1, 2, 3. So at least I want to write 3 times. Please tell when what is when n equal to 1. When n equal to 1, this is 1 by 1 square. Here sine pi x by 2. Next, n equal to 2 means this is minus 1 by 3 square into sine 2 means sine 3 pi x by 2. Okay, and the n equal to 3 means plus 1 by 5 square into sine 5 pi x by 2. So and the minus 1. So this is a most general term. Okay, so you can stop here. So just I want to check it, but just I want to check it, the book answer. Actually, in the book they gave this answer. Okay. The next problem. Yeah. Find the half range sine series of f of x is equal to x into cos x in the interval 0 comma pi. Uh, we need a half range sine series. So f of x is, what is L here? L equal to pi. Yeah, L equal to pi. So half range sine series is f of x is equal to n equal to 1 to infinity bn into sin n pi x by L. L is pi gets cancelled. Now bn, we need to find bn. Bn equal to what? 2 by L, L is pi, integration 0 to L, L is pi. Uh, f of x, what is f of x? X into cos x, please write.
Sir, you are not audible, sir. Sir, you are not audible, sir.
So you have muted yourself. So you have muted yourself.
Yes. So, because I want to talk to Kiva, that's why I muted. Again, I forgot it. Okay, thank you, Jay. Uh, find half range sine series of f of x is equal to x cos x in the interval 0 to pi. Uh, okay, here L is pi. F of x is what? F of x is summation n equal to 1 to infinity bn into sine n pi x by L. L is pi, pi gets cancelled. What is bn? Bn equal to 2 by L. L is pi. Integration 0 to L. L is again pi. F of x. What is f of x? X into cos x into sine n pi x by L. L is pi. Pi gets cancelled into dx. Okay. So 2 by pi integration from 0 to pi 0 to pi. First, I will write sine nx and then I will write cos x into dx. So this is 2 sine a cos b. So that is what? Sine of a plus b plus sine of a minus b divided by 2. We can cancel this 2 and 2. So next step, I split into two integrals. One is from 1 by pi 0 to pi x into sine n plus 1 x into dx. The other one is 1 by pi integral 0 to pi x into sine of n minus 1 into dx. So there are two integrals. Now, as usual, we need to integrate. So 1 by pi, keep x. If you integrate sine n plus 1 x, we have minus cos of n plus 1 x divided by n plus 1 minus, if you differentiate x, 1. If you integrate this function, we'll get minus sine of n plus 1 x into x by n plus 1 whole square. Limit is from 0 to pi. And then I need to integrate the second integral, 1 by pi, keep x. If you integrate sine of n minus 1 x, we'll get minus cos of n minus 1 x divided by n minus 1. To differentiate x, we get 1. To integrate this function, we get minus of sine of n minus 1 by n minus 1 whole square, 0 to pi. Okay. So now we need to substitute the limits here. Limits. Okay. So here minus 1 by pi into n plus 1. I took commonly. You can check it here. Minus pi divided by n plus 1. Remaining is what? x into cos n plus 1 x. X is equal to pi. So pi into cos n plus 1 pi. Cos n plus 1 pi is minus 1 whole power n plus 1. So pi into minus 1 whole power n plus 1 minus sine of sine n plus 1 pi is 0. So sine n plus 1 pi is 0. So that's why this is 0. And then I think I forgot to write. Please check it. I will check it. Yes. I just only write the upper limit. Lower limit is what? When x is equal to 0, 0, sine 0, 0. Okay. So I need to write here. Yes. This is upper limit minus lower limit is 0 when x is equal to 0. Here also 0, sine 0, 0. So plus 0. Okay. So similarly, in the second integral, minus okay, sorry. So it is better to write this is 0. Okay, because sine of n plus 1 pi is 0, sine 0, 0. Similarly, this is 0 because sine of n minus 1 pi and sine 0, 0. So there is no need to write this one. So that's why I kept like this. This is pi. So again, I will tell you. So these two are 0. So what is common here? Minus 1 by pi into n plus 1 minus 1 by pi into n plus 1. X is equal to pi cos of n plus 1 pi. So pi into minus 1 whole power n plus 1. Okay. And then when when x is equal to 0, here lower limit is 0. This 0. Okay. Similarly, here minus 1 by pi into n minus 1 minus 1 by pi into n minus 1 upper limit when x is equal to pi. Okay, cos of n minus 1 pi is what? Minus 1 whole power n minus 1. Okay, minus lower limit when x is equal to 0, 0. Okay. So now from these two, just I am going to multiply. If I multiply pi gets cancelled. 1 by n plus 1 into minus 1 whole power n plus 2 because here we have minus sign n plus 1, so n plus 2. If I multiply these two, we have pi gets cancelled. 1 by n minus 1, here we have minus sign, so here we have n minus 1, so minus 1 whole power n. Okay. So minus 1 whole power n plus 2 is same as minus 1 whole power n. So that's why I took commonly minus 1 whole power n into 1 by n plus 1 plus 1 by n minus 1. So I took LCM n square minus 1. That is, if you cross multiply n minus 1 plus n plus 1, plus 1 minus 1 gets cancelled. So the numerator is what? Minus 1 whole power n into 2n by n square minus 1. Okay. So this is true for every n which is not equal to 1. So we need to find the b1 separately. So b1 equal to 2 by pi integration 0 to L is pi. F of x is what? X into cos x into sine n is 1 pi x by L is pi gets cancelled cos then we have sine x. So sine x into cos x is sine 2x by 2. So again integration, so 2 gets cancelled, 1 by pi, keep x, if you integrate sine 2x you have minus cos 2x by 2, minus if you differentiate x you have 1, To integrate this function, have minus sine 2x by 2 into 2, 4, 0 to pi. So this is 0 for both upper limit as well as lower limit. Remaining have minus 1 by 2 pi. Okay, when x is equal to pi, cos 2 pi is 1. When x is equal to 0, lower limit is 0. So pi gets cancelled, minus half. So b1 equal to minus half. So half range sine series is what? B1. B1 is, we know that minus half into sine x plus n equal to 2 to infinity 2n. 2 is constant, so that's why I'll write it 2 outside the summation. 2 into summation n equal to 2 to infinity minus 1 whole power n divided by n square minus 1 into n into sine nx. So I think you can stop here. Uh, okay. The next problem is obtain sine series and cosine series for f of x is equal to x into pi minus x in the interval 0 to pi. Okay. Also deduce that summation n equal to 1 to infinity minus 1 whole power n plus 1 divided by 2n minus 1 whole cube is equal to pi cube by 32, and we need to deduce this sum is equal to pi square by 12. Okay. So here you can see that L equal to pi. Okay. L equal to pi. First sine series. First I need to find the sine series. So what is sine series? F of x is equal to summation n equal to 1 to infinity bn into sine n pi x by L. L is pi gets cancelled. Okay. So now I need to find bn. I need to find bn. Bn equal to what? 2 by pi. Integration from 0 to pi. L is pi. F of x. What is f of x? X into pi minus x square. That is pi x minus x square into sine nx dx. Okay. So now, by Bernoulli's we have 2 by pi. So keep pi x minus x square as it is. If you integrate sine nx, you have minus cos nx by n. Okay, minus, you should differentiate pi x minus x square. So then you have pi minus 2x. If you integrate minus cos nx, you will have minus sine nx by n square. Plus, if you differentiate pi minus 2x, you'll get what? Minus 2. If you integrate minus sine nx by n square, have minus of minus plus cos nx by n cube. Limit is from 0 to pi. So this is 0 for both upper limit as well as lower limit, because sine n pi 0, sine 0, 0. And this is also 0 for both upper limit as well as lower limit. The reason is when x equal to pi square minus pi square 0. When x is equal to 0, here also you have x, here also you have x. So first and second terms are 0. So only you have the third term. So what is the third term? You have minus 2 into minus 2 minus 4 by pi n cube. Okay. Cos n pi is what? Minus 1 whole power n minus cos 0 is 1. So now I took minus 1 commonly. So I took minus 1 commonly. Next one. Okay. Sorry. So I think we are discussing this one. Is it correct?
Yes, sir.
Okay, please write. I think I need to delete this one. This is unnecessary. I think we are discussing this problem. Okay, I think this type. So I took minus 1 commonly. If I took minus 1 commonly, we have Bn equal to 4 divided by pi nq into 1 minus of minus 1 whole power n. So this is your Bn. When n is even, 1 minus 1, 0. Okay, when n is odd, you have this is 2. Okay, totally 2 into 4, 8 by pi n cube. Okay. So Bn equal to 0.
Just like for a minute, sir.
Okay.
Just 1 minute, sir. Yes, sir. Thanks, sir.
Okay. So when n is even, this is 0. If when n is odd, odd means this is 2 to 8 by pi n cube. If n is odd, so f of x is equal to, what is f of x? When is even 8 by pi summation n equal to 1 3 pi and so on up to infinity 1 by n cube into sine nx. Okay, sine nx. Okay. So now you can simplify further. This is f of x is equal to 8 by pi. So if you want to substitute n equal to 1 to infinity, you can write this is 1 by 2n minus 1, 1 by 2n minus 1 whole cube into sine of 2n minus 1 into x. I call this is equation 1. So now we need to derive some result. So there are two results. So I think we have like this. Okay. So so we need to substitute for x equal to what? Substitute x is equal to
pi by 2.
pi by 2. Okay, yeah. And x equal to pi by 2. Okay, so let's try. In 1. So we know that x equal to pi by 2 is a point of continuity. So f of pi by 2 which is equal to 8 by pi 8 by pi into summation n equal to 1 to infinity 1 by 2n minus 1 whole cube into sine 2n minus 1 into pi by 2. Okay. So now what is the left hand side? We have the function, what is f of x? X into pi minus x. X into pi minus x means pi by 2 into pi minus pi by 2. This is equal to 8 by pi. Substitute n equal to 1 directly. If we substitute n equal to 1, sine pi by 2 divided by 1 cube plus n equal to 3 means n equal to 2 means n sine 3 pi by 2 divided by 3 cube plus n equal to 3 means sine pi by 2 divided by 5 cube and so on. So this is equal to, this is pi by 2, so pi square by 4. So 8 by pi. So this is actually 1 by 1 cube. Sine 3 pi by 2 is minus 1 by 3 cube. Sine 5 pi by 2 is 1 by 5 cube. And then minus and so on. So which is equal to, I need only this series. This is equal to pi cube by 32. Equal to pi cube if you want to write in the short form, summation n equal to 1 to infinity minus 1 whole power
n plus 1.
n plus 1 divided by
2n minus 1 whole cube.
2n minus 1 whole cube. Thank you. Which is equal to pi cube by 32. So I think we solved the first part. First part is what? Sine series. Similarly, we need to derive for cos series.
Sir,
Please tell.
sir, instead of splitting the terms,
Ah.
can we directly substitute sine 2n minus 1 pi by 2 equal to minus 1 for n plus 1?
Sine 2n minus 1 pi by 2 equal to minus 1 whole power n plus 1. Yeah, you can do it. Yeah. Actually, we done it in the previous problem also, the same manner. You can replace this by, directly you can substitute this one by minus 1 whole power n plus 1. You can do it.
Okay, sir.
Yeah. So I need to do one more thing. Cos series. Yeah, that is the subdivision 2. Half range cosine series. So please check it whether this is comes under this column. Maybe I will write wrongly. Okay, well, so please check it. Half range cosine series. Actually, this is the subdivision 2 in the previous column. Okay. Yeah, this is over. First part. So here f of x is what? A naught by 2. A naught by 2 plus summation n equal to what? N equal to 1 to infinity into an into cos n pi x by L. L is pi gets cancelled. So we need to first find a naught. A naught is what? 2 by L. L is pi. Integration 0 to L. L is pi. F of x is what? X into pi minus x into dx. So 2 by pi 0 to pi x pi minus x square into dx. I think you can easily find the a naught. So I don't want to spend the time here. So a naught is pi square by 3. Next an. An is what? 2 by L. L is pi. Integration from 0 to pi. F of x is x into pi minus x into cos nx. So now you need to integrate this. Okay, so I need to do it, integration. So an equal to an equal to 2 by pi, yeah, 2 by pi, pi x minus x square, okay, into sin nx. Sin nx, if you integrate, at least you can leave some space for a naught and then you can continue a. If you integrate cos nx, you'll get sin nx by n. Okay, minus if you differentiate this, you'll get pi minus 2x, pi minus 2x. If you integrate this, you'll have minus cos nx by n square. If you differentiate this, you have plus minus 2 into, if you integrate minus cos nx by n square, you have minus sin nx minus sin nx by n cube. Limit is from 0 to pi. Yeah. So the first term and the third term are 0. So only have the second term. So this is equal to minus of minus plus 2 by pi n square. Okay, upper limit is when x is equal to pi, you have what? Pi minus 2 pi. Pi minus 2 pi is minus pi. Otherwise, I'll write one more step. You have what? Pi minus 2x into cos nx. Limit is from 0 to pi. Now you can substitute 2 by pi n square. Upper limit is uh, pi minus 2 pi is minus pi. Cos n pi is minus 1 whole power n. Minus when x is equal to 0, you have pi. Cos 0 is 1. So it took commonly minus pi. So minus 2 pi minus 2 pi by pi n square into minus 1 whole power n plus 1. So pi gets cancelled. So an equal to minus 2 by n square into,
Sir,
yeah,
sir, 1 minute, can you show previous slide?
okay.
Sir, I think you missed a minus sign.
There. Here. Large, yeah.
Sir, I think it is correct only.
Okay. Okay. So we'll proceed. Thank you, Sheila. So minus 2 by n square minus 1 whole power n plus 1. So pi gets cancelled. Minus 2 by n square minus 1 whole power n plus. So this is your a. When n is odd, this is minus 1 plus 1, 0. So an is 0 if n is odd. When n is even, this is 2 into minus 2 minus 4 by n square when if n is even. Okay, so now so we need to find f of x. What is f of x? F of x is equal to a naught. What is a naught? Pi square by 3. So a naught by 2 is pi square by 6 minus 4. A you have 4. N equal to 2 to infinity, 2, 4, 6 up to infinity, because n is even. When n is odd, a n is 0. So 1 by 4 by n square into cos nx. So now I am going to write n equal to 1 to infinity, replace n by 2n. So f of x is equal to pi square by 6 minus 4 into summation n equal to 1 to infinity 1 by 2n whole square into cos 2nx. So 4 gets cancelled. So f of x is equal to pi square by 6 minus summation n equal to 1 to infinity 1 by n square into cos 2nx. Okay. So I think now we need to derive a series for I think yes, that is summation this series minus 1 whole power n plus 1 by n square is equal to pi square by 12. Okay.
Sir,
Uh,
for doing this, sir, for cosine series we need to prove one thing, and for sine series we need to prove another thing.
yes.
Sir, but
That is why uh, uh, you need to actually, yes, you are right. You are right. What is your question? First you will ask.
sir, in the question they have just given that reduce that this and that like that they have given.
Yes.
So then
How
how,
we know whether this one you should use for sine series, this one is for cosine series? This is
yes,
your
sir.
question. Is it correct?
Yes,
Yeah.
sir.
That is by observation. Observation means, okay, sorry. Here you have what? 1 by 2n minus 3 whole cube. So this is the indicator. So we should derive the first one. Okay. So in the second one, we have 1 by n square. Here you can see here 1 by n square. Okay. So this is the way you can judge. You should derive the series and then finally you should decide. Okay.
Oh, okay, sir.
Okay. So now the thing is you should substitute what is x here. Okay, x is equal to what? Sheila. Sheila is here.
Yes, sir. 1 minute thinking, sir.
Yeah. Okay. Okay. Or anybody.
Sir, pi by 2.
Yes, correct.
Yes,
Sure.
correct. Sure.
So x equal to pi by 2. So when x equal to pi by 2, okay, check it. I think it is correct. Uh, x equal to pi by 2 is a point of continuity here. So now when x equal to pi by 2, this is f of pi by 2, which is equal to pi square by 6 minus summation n equal to 1 to infinity 1 by n square. When x is equal to pi by 2, 2 gets cancelled. We have what? Cos n pi. Yeah. Cos n pi is minus 1 whole power n. So pi square by 6. Here have minus sign. Okay. N equal to 1 to infinity 1 by n square. This is minus 1 whole power n. What is f of x? I think x into pi minus x. So pi by 2 into pi minus pi by 2. This is pi by 2, pi by 2. So pi by 2 into pi by 2, pi square by 4. Pi square by 4, which is equal to pi square by 6. This is minus 1 summation plus summation n equal to 1 to infinity 1 by n square, sorry, minus 1 whole power n plus 1 by n square. I think we need this series. We need this series. You can check it. So that is equal to summation n equal to 1 to infinity minus 1 whole power n plus 1 divided by n square, which is equal to pi square by 4 minus pi square by 6, or this is equal to if you take 12 is LCM, 3 pi square minus 2 pi square, so pi square by 12. So this is the final answer. Okay. So next, let's start Parseval's identity. Parseval's identity for Fourier series, the first one. Similarly, Parseval's identity for Fourier cosine series, and then Parseval's identity for Fourier sine series. Parseval's identity or Parseval's theorem. So usually Parseval's identity or Parseval theorem is useful to deduce the results. So up to I think in the previous problem, we are substituting x equal to pi by 2, x equal to 0, x equal to pi, okay, by observation. But here also we need to derive the series, not substituting the values of x, but using Parseval's identity, we will derive. So again, there is one student is asking question. So how we will know to derive this series? We need to use Parseval's identity. Okay, the question will rise. I will tell you how to identify. Okay. So first, before going to the problem section, first we will prove Parseval's identity for Fourier series. So this is a statement. If f of x is any function of x defined in the interval c to c plus 2l, satisfying Dirichlet conditions, and if f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an into cos n pi x by l plus bn into sin n pi x by l, because this is equation 1, where a naught equal to 1 by l integration c to c plus 2l f of x dx, an equal to 1 by l integration c to c plus 2l f of x into cos n pi x by l into dx, and bn equal to 1 by l integration c to c plus 2l f of x into sin n pi x by l into dx. So then Parseval's identity is integration c to c plus 2l into f of x into dx, c to c plus 2l f of x whole square. Okay, so this is a RMS value. I will define RMS value later. Okay, c to c plus 2l f of x whole square into dx is equal to 2l into a naught square by 4 plus 1 by 2 summation n equal to 1 to infinity an square plus bn square. So this is the Parseval's identity. So we are going to prove a theorem. So proof is simple. Multiply equation 1. Equation 1 is, this is equation 1 by f of x and integrate with respect to x. Between integrate with respect to x between c and c plus 2m. So we get, so okay, integration. Okay, integration. We need to multiply by f of x. We need to multiply by f of x. So f of x into f of x whole square into, and then you need to integrate from c to c plus 2l. This is the left hand side. Right hand side, a naught by 2. A naught by 2. You need to must to multiply by f of x and then integrate the c to c plus 2l into f of x into dx plus summation. I will write summation. So I am going to integrate integration. I am going to take into the summation. Okay, so summation. First I will write summation n equal to 1 to infinity an. Okay, an. Now integration c to c plus 2l. You have here what? Cos n pi x by l, but I am multiplying by what? F of x. So f of x into, there you have cos n pi x by l into dx. Okay, and then plus summation n equal to 1 to infinity bn. Next, summation n equal to 1 to infinity bn integration c to c plus 2l, because we need to multiply by f of x into remaining is what? Sin n pi x by l. Into dx. Okay, once you've done this step, remaining everything is just a substitution. So here what I done, first I multiply by f of x and then I am integrating with respect to x from c to c plus 2. So now what is integration c to c plus 2l f of x dx? This, it is nothing but what? A naught into L. Is it correct?
Yes, sir.
Yeah, okay. So which is equal to A naught by 2 into A naught into L plus summation n equal to 1 to infinity. Actually, this summation n equal to 1 to infinity is common. So that's why I took commonly. Summation n equal to 1 to infinity commonly. into an. Okay, what is integration c to c plus 2l f of x into cos n pi x by l into dx?
An into L. Sir.
An into l, correct, Sheila? An into l plus bn, okay, and similarly integration c to c plus 2l f of x into this function is bl into bn into l or l into bn. So now this is equal to l a naught square by 2. Here l is common, summation n equal to 1 to infinity an square plus bn square. Okay, so now you have here you have 2l. Here you have 2l. That's why I'm going to multiply and divide by 2l. Multiply and divide by 2l. So I keep this 2l here. I keep this 2l here. Now I am going to, here you have 2l means if we multiply by 1 by 2l, you have what? L gets cancelled. A naught square by 4 plus LL gets cancelled 1 by 2 into summation n equal to 1 to infinity an square plus bn square. So this is a proof. So next one is Parseval's identity for cosine series. What is the left hand side here? The left hand side is here C2 C plus 2L f of x whole square into dx. So this is a Parseval's identity for Fourier series. So next, for Parseval's identity for cosine series means you should write the left hand side is C2 C plus L instead of C plus 2L. Okay, I think I done it wrongly here. It should be L C plus L. The integrand is same f of x whole square. Okay, but here you have 2L, here you have L. Okay, what is here you have what? A naught square by 4 plus 1 by 2. Here you have an and bn. But here you have a naught square by 4 plus 1 by 2 summation n equal to 1 to infinity only an square. Similarly, Parseval's identity for sine series. Integration from C to C plus L f of x whole square dx is equal to L into a naught and a n term will not come here. So just 1 by 2 summation n equal to 1 to infinity bn square. Okay. So now at least we will solve one or two problems in using Parseval's identity now. The first problem is find the Fourier series for f of x is equal to x square. Okay, x square in the interval minus pi to plus pi, and deduce that this. So now we can solve this problem quickly because we know a naught and an, because this function is even. I think yesterday also we discussed this problem in the triple E class. I think Varsha also told that What is A naught and AN? I think this is the second problem we solved in the classroom.
Yes, sir.
Yeah, what is A naught?
Sir, A naught is 2 pi square by 3.
Yeah, 2 pi square by 3. Okay. What is AN, Sheila? So please verify it. It's 4 times
-1 whole power n
minus 1 whole power n.
by n square.
Thank you, Vishal. Minus 1 whole power n divided by n square. And the Bn is 0. Okay. Now, what is f of x? F of x is equal to a naught by 2. A naught by 2 is pi square by 3 plus 4 times summation n equal to 1 to infinity minus 1 whole power n divided by n square into cos nx. So now, okay, here have n square, okay, 1 by n square. Here have 1 by n power 4. Suppose if you square of this, okay, if you square if you square n square, if you have n power 4, so then you should use a Parseval's identity. Suppose if we have here n, here have n square, so then you should use Parseval's identity. So if you just substitute x is equal to pi by 2 or x equal to 0, you never get this series, because here have 1 by n square, here have 1 by n by n power 4, here have 1 by n square. So this is the idea basically. So now Parseval's identity. Actually here you need to use, there are 3 series. Parseval's identity Fourier, Parseval's identity for Fourier series, Parseval's identity for half-range sine series, Parseval's identity for half-range for half-range cosine and half-range sine series. Here you need to use which one?
Cosine series.
Is it correct? Yeah, you can use cosine series, but here the problem is what? It is a Fourier series. They are not asking what Fourier cosine series, because this is an even function. That's why that's why Bn is 0. That's why Bn is 0. So it is better to use here. So, but I think my suggestion is it is better to use here for your series for Parseval's identity. So you can later verify it whether if you use cosine series, whether you are getting the same answer. Okay.
Yes, sir.
Okay. Now, Parseval's identity. Identity is integration c to c. First I will write c to c plus 2l f of x whole square into dx is equal to 2l into a naught square by 4, a naught square by 4 plus half the summation n equal to 1 to infinity an square plus bn square. Okay, so now here what is the limits? We have minus pi 2 plus pi r. F of x is what? x square whole square dx. 2l, L is pi. A naught, 1 by 4. What is A naught? 2 pi square by 3. So 2 pi square by 3 whole square plus 1 by 2 summation n equal to 1 to infinity an. What is an? 4 into minus 1 whole power n by n square. 4 into minus 1 whole power n by n square whole square. Okay. So this is x power 4. X power 4 is the even function. So you can write this is a 0 to pi x power 4 into dx. So now this is 2 pi. Okay. To simplify, we'll have 2 square 4 gets cancelled. Pi power 4 by 9 plus 4 square 16 by 2 is 8. 8 summation n equal to 1 to infinity minus 1 whole power 2n is 1 by n square whole square is n power 4. So the left hand side is what? 2 into x power 5 by 5. Limit is from 0 to pi. Okay. This is equal to just you can I think you can cancel this 2 and 2. Okay, 2 and 2 gets cancelled. So pi power 5 by 9 plus 8 pi summation n equal to 1 to infinity 1 by n power 4. Actually, I need only this series. So pi power 5 by 5 upper limit minus 0 minus pi power 5 by 9 equal to pi 8 pi into 8 pi into summation n equal to 1 to infinity 1 by n power 4. So this is if you take 45, if you take 45 LCM, 9 pi power 5, this is 5. So 4 pi power 5, okay, into 1 by 8 pi, which is equal to summation n equal to 1 to infinity 1 by n power 4. So this implies a summation n equal to 1 to infinity 1 by n power 4 is equal to, this is actually 45. It looks like it's a 4 power 5. So 90, yeah, pi power 4 by 90. So this question is asked like this. Okay. So find the Fourier series for f of x is equal to x square in this interval. Reduce this series, and also I gave two series in the second column. I think Vishal and Sheila told that you can see there are two more series we reduced. Is it correct? Is it correct?
We will try, sir. We'll not yet try. We'll try and
Sorry, Vishal.
we not yet tried, sir. If we will try and check it out.
Okay.
Thank you.
Yeah. No. I am asking. In the problem f of x equal to x square minus pi to plus pi, I think I gave two more series.
Yes, sir.
I will tell you. Summation, three more series actually. Summation 1 by n square, summation minus 1 whole power n plus 1 by n square, summation n equal to 1 to infinity 1 by 2n minus 1. We derived three series.
Sir, we
Okay, wow.
also did that 1 by 1 square minus 1 by 2 square.
Yeah. So if they mix that series and this series, you should be a little bit careful. Okay. So you should identify for which one we need to substitute x value, for which one you need to use Parseval's identity. Okay. So I already told that here you have n square, here you have n power 4. Then you should go for uh, Parseval's identity. I think Vishal also told that we can use here Parseval's identity for for the cosine series. I think to use cosine series, we will get the answer correctly. I think so. So, but I'm not checking. But my guess is we will get the correct answer. Please verify, Vishal. You can tell tomorrow. Okay.
Okay, okay.
Uh, and I don't want to do this problem now. I'll do it Monday. But okay, again, I don't want to do this problem now. Okay, this is a practice problem. But if possible, you can try this problem for your cosine series. So try to find what a naught and an. So if you solve these two, then my problem is easier. Then directly I will find this, because we discussed so many problems. Okay, and then similarly in this problem, we need to find half range sine series. So at least you should find the bn. Once you find the bn, we will discuss only this portion in the classroom. Okay. So this problem you should do is as a practice problem, because it's a small function of x equal to x. You should find half range cosine series and half range sine series in the interval 0 to L, and then you need to reduce. Okay, you need to reduce. Okay, and then last problem. Last problem. Yes, prove that for 0 less than x less than pi, pi x minus x square equal to pi square by 6 minus cos 2x by 1 square plus cos 4x by 2 square plus cos 6x by 3 square, and so on. So deduce that summation n equal to 1 to infinity 1 by n power 4, which is equal to pi power 4 by 90. Whether we solve this problem or not today, that's I am asking.
So just now we did sigma n is equal to 1 to infinity 1 by n.
Yeah, that is a series. What about actually this function is what? This function is
Last problem in half range with this.
yeah. Please tell Jaya. Pi. Sorry. Actually, this function is f of x is what? X into pi minus x. Okay, wow. So I think we solved some problem x and yes. So please check it. Obtain sine series and cosine series for the function f of x is equal to x into pi minus x in the interval 0 less than x less than pi. Okay, va? So I think this is also, suppose this problem is asked, how you will approach, how you will solve this problem.
Sir, we can use Fourier cosine series.
Correct.
Partial cosine series.
Yeah, Fourier cosine, half range cosine series. The reason is the interval is what? 0 to pi. Okay. And here have only the cosine terms. But it is not mentioned here. You need to use half range cosine. But from the interval and from the answer, you should understand, you should use half range cosine series. But already we solved this problem. What is A naught? Please tell Jaya or anyone. Just now we solved the classroom.
Pi square by 3.
Yeah, pi square by 3. Yes, correct. A naught is pi square by 3. And an is what?
So 2 by n square into 1 plus minus 1.
Yeah, minus 2 by n square. Minus 2 by n square into minus 1 whole power n plus 1. Is it correct, Jaya?
Yes, sir.
Okay. So now I think an you can simplify further. When n is odd, this is 0. Okay. When n is even, this is 2. So minus 4 by n square. And equal to 0 when n is odd. Okay. So now what is f of x? F of x is equal to, I think f of x also we got it. Is it correct?
Yes,
So,
sir.
yeah, please tell. What is f of
Pi
x?
square by 6
Pi square by 6.
minus summation 1 by n square.
N equal to 1 to infinity.
Yes, sir. 1 by n square cos 2nx.
Yes, correct. Thank you, Jaya. 2nx. Okay. So I call this is 1. So here you have n square. Here you have n power 4. So you need to use a partials. Okay. So I think this is for half range cosine series. So you should apply partials identity for cosine series. So what is partial identity for cosine series integral 0 to pi f of x whole square into dx is equal to L. L is pi 1 by 4 into a naught square. A naught is what? Pi square by 3 whole square plus 1 by 2. 1 by 2. Please check it. What is check it. Plus 1 by 2 summation n equal to 1 to infinity, summation n equal to 1 to infinity a n square. What is a n square? Or you can write first, uh, first instead of writing directly, if you want to write, because is when n is even, this is n equal to 2, 2, 4, 6 up to infinity. We have what? Minus an is what? Minus 4 by n square whole square. This is a square. Now close the bracket. So now the left hand side is what? F of x is what? Pi x minus x square. 0 to pi x minus x square whole square into dx. The right hand side is what? Pi into pi power 4 by 9 into 4, 36 plus 16 by 2 is 8. 16 by 2 is 8. Summation, if you want to write n equal to 1 to infinity, this is actually 1 by n power 4. Replace n by 2n, that is 2n power 4. Now, the left hand side is just to expand it. It is the left hand side. Interval 0 to pi. Please tell. Pi square x square plus x power 4 minus 2 pi x cube into dx, which is equal to, right hand side is what? Pi power 5 by 36 here we have 2 power 4 16, so 1 by 2 or pi by 2 summation n equal to 1 to infinity n power 4. So now integration, so pi square into x cube by 3 minus plus x power 5 by 5 minus 2 pi x power 4 by 4, limit is from 0 to pi. So this is equal to pi power 5 by 36 plus pi by 2 into summation n equal to 1 to infinity 1 by n power 4. So this is actually what? Pi power 5 upper limit 3 plus pi power 5 by 5. Here you have 2 pi power 5 by 2. Lower limit is 0. Lower limit is 0. Okay. You see, which is equal to pi power 5 by 36 plus pi by 2 into summation n equal to 1 to infinity 1 by n power 4. So if you take 30, you have what? 10 plus 6 minus 15 into pi power 5 minus pi power 5 by 36, which is equal to pi by 2 summation n equal to 1 to infinity 1 by n power 4. So this is what 16, 15, 15 by 30. So pi power 5 by 30 minus pi power 5 by 36 into 2 by pi, which is equal to summation n equal to 1 to infinity 1 by n power 4. So from this, pi power 4, because can take pi power 5 by pi is pi power 4. 1 by 30 is 15 minus 1 by 18. So if we have take 180 as LCM, pi power 4 into 12 minus 10. So 2 by 180, 2 by 180 is 1 by 90. So pi power 4 by 90. So this is the final answer. So I think I've done some problem today, but I am expecting at least some of you should solve problem 3. Okay, well, I will do this part. Okay, at least BN. Here in problem 2, A0 and A. So Monday class I'll start 7:30 to 8:30. So I will try to finish in the next week Fourier series. Before
Previous page, so once.
previous slide, some okay. Here this one.
Yes.
I think not this slide. Actually, I done the last problem is here. This one. You are asking this problem or that problem?
Yes, this problem, sir.
This problem. This slide, is it correct?
Yes, sir, done, sir.
Okay. Are you finished, Varsha? Varsha still writing this one?
Sir, I think she left due to some network errors.
Oh, network connection. Okay, thank you, Sheila. Okay, anyway, so we will meet Monday 7:30. Okay, thank you.
Thank you, sir.
So, okay, thank you, everyone.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you, Ma. Thank you, Ashli.